Hello everyone. Previously, we had discussed how to make use of the begin for large numbers. We had seen the examples as well, right? So today we'll be dealing with, we'll be discussing on data structures and advanced data structures in JavaScript like tree, heap, etc. So I have already solved many problems in LeetCode and the Codeforces. So I have made the videos of it, kept it in the separate playlist. So I have solved many problems on DP, segment tree, and Fenwick tree, and other concepts as well. It may be priority queue, min priority queue, and other concepts as well, graphs, other concepts. So you can see that. So today I'll just, for the this sake, I'll just be explaining try and heap. The simple how to implement simple try and heap. Right. So let's see. Basically, what are the advanced data structures in JavaScript? Basically, try and heap. I said I'll be explaining try and heap. Right. So JavaScript supports implementing advanced data structures like tries and heaps for efficient data processing. So first, initially, let's see the try implementation. Next, we will see the MinHeap implementation. So let's begin with the try implementation. Let's implement a try for the word insertion and search, right? Again, I'm telling we are implementing a try for word insertion and search, right? I'll just come here quickly. Let me give class try node. So within this, let's make use of the constructor, right? So within constructor, let's assign two things. One is children to the empty object, and the next one, I'll just consider the variable, this one, this is end. I'll just consider this one and assign this one to Boolean value false. I hope this is clear, right? So just give me a second here. Yeah, I'll just make use of class try here. So within this, let me make use of constructor again. I'll just give here. Let me give constructor. So within this constructor, this time I'll consider root. Root, I'll just assign this one to new, this one, new node, right? I'll just give here new try node. So as I've said, what we are doing here, what we are implementing with the try, we are implementing a try for the word insertion and search, right? So initially, let's go with the insert method. I'll just give here insert of what shall be pass here, word, insert of word, right? So I'll quickly come here. Let me give let node equals this dot this dot root, and let's make use of the for loop for the iteration, right? I'll quickly give for const char of word, individual characters of the word we are considering, right? If, let me quickly make use of the if condition. If not of node dot children of the char within the this one array, right? So I'll just assign the children of the node, so nothing but the char within the array, to new try node. This is simple, right? Then let's assign node to children. So here it will be node dot children of char within the array. So I hope this is clear. Next, initially we have set the is end to false here, Boolean value false. Now we will set this one to true, right? So I'll just come here, node dot is end. Let's set this one to true here. Hope this is clear. This is it for the insert. So we are inserting character by character, right? So this is for the insertion of the word. Next, as I have said, we are implementing a try for the word insertion, also for the search, right? Let's go with the method search now. I'll just give here search of word and pass the word. Initially, I'll just give simply let node equals just dot root, and same thing again. I'll just go with the for loop for const individual char of word, then if not of node dot children char. So we will just return false if character that we are searching, if it is not present in the node, then we are returning false in the children, right? If it is not present in the root of the children, we are just returning false. It's simple, right? So let's assign node to node dot children of cap within the array. So let's now return the same thing. We will return node dot isend. So this is clear. Next, what I'll do, I'll just consider let trie equals, sorry, I'll just make use of the new keyword, new trie we are creating. So then let's make use of the insert method. So what we are inserting here, I can insert anything. In my case, I'll just insert Bharadwaj, right? So let's log something so that we'll get to see the output, right? So I'll just give here try dot first let's go for the search. We have already made use of the insert, right? We are inserting the this one Bharadwaj. So let's search for I'll just come here. Let's search for, I'll do one thing. Let's search for the entire thing. Bharadwaj we have considered, right? We have inserted the this one text Bharadwaj. So let's search for the Bharadwaj itself. So we, if everything goes well, we have written the, if we have written the current implementation, if I give the search of Bharadwaj, it has to give the boolean value true because we have inserted the text Bharadwaj over here, right? So next, let me log one more thing here. Half of it, suppose like BHA, something like that, right? So we don't have the term BHA, we have the complete term Bharadwaj we have inserted. So this has to give us the output false. So let's see what happens here. So I forgot try.search here. Just give me a second here. Let me quickly give here. Yeah, let me close the parenthesis as well. Yeah, if I let me try running the code. So line number 3, this has to be, let me run the code again. Yeah, you can clearly see here. First thing, we have inserted the Bharadwaj here. We had inserted the text Bharadwaj. So when we try to search this one by making use of the method search that we have written here, the code. Clearly you can see here, insert in the search we have written, right? As I have said, we are implementing a try for the word insertion and the search. We are inserting a term text Bharadwaj. When we try to search for Bharadwaj, we will get the boolean value true. We have complete this one, right? Complete text Bharadwaj. If I try to search for BHA, the complete text BHA is not there, and we will get the boolean value false for this as per the code that we have written. I hope this concept is completely clear. So let me quickly delete this one. Yeah. Now what we have seen here, we have seen the we saw the try implementation, right? So how to implement a try with the word insertion and search. So now let's quickly try to implement the MinHeap with the insertion and extraction. Let's again, I'm telling, we will be implementing a minimum heap or min heap with insertion and extraction, right? So let me quickly come here. I'll just give here class min heap. Let's make use of the constructor. Within the constructor, I'll just define heap to the empty array. Hope this is clear. So next step, what we are doing here, we are going with the insert, bubble up, extract min, as well as sync down methods. So let's see what these methods basically do. I'll just come here. Let me insert the value. So I'll just pass the val. So let's set the heap. So let's push the value to the heap, right? Initially, let's push the value to the heap by making use of the push, right? So then I'll just give here this dot bubble up. So I haven't written the bubble up method yet. So we'll be writing that bubble up method next. So am just writing it before itself. So I'll just come here. Let me quickly write here bubble up method. So here what I'll do, I'll just come here. I'll consider the IDX or the index. So this one has to this one, I'll just assign this one to the last element, nothing but this dot length minus 1. I'll quickly come here. Let me give length minus 1. And while here I'm just considering the last index or the last element, nothing but I'm assigning the index to the last element here. So while index is greater than 0, so it has to be true at any cost, right? So while index is greater than this one 0, let's go with parent index equals, let me make use of the math.floor, or you can go for the tilde operator as well. I'll just make use of math.floor very quickly. So idx index minus 1 I'll keep quickly by 2. So I hope this is clear. Let me quickly write the if condition. This dot heap of, let me pass the parent index. So this, if it is less than or equal to normal index, nothing but this dot heap of idx index, then we are breaking out of the loop, right? Then I'll just quickly give here this dot heap of parent index, this dot heap of normal index. This one we will assign this one to index and the parent index, nothing but we are swapping over here. We are setting within the arrays, we are swapping the elements, right? We are setting the parent index to index and we are swapping the parent index as well as the index. That's it. That's it. You have to remember. I'll just copy the same thing over here. Just give me a second here. What is happening? Let me quickly come here within the array. Let me paste the same thing, and also let me come here. Let me copy this one. Just give me a second here. Did I miss anything? Just give me a second here. Yeah, I'll come here quickly. So here there is no this thing, or what do you call, or no need of the square braces here. So this is fine. So after bubble up operation, so I quickly I'll just set the index to parent index. So we are just swapping over here, right? So next we will see the extract min method. So I'll just quickly give here extract min. So initially what I'll do here, if the length of the heap is 0, then we will be returning null, right? We have to pass certain object. So if the length of the heap is 0, then we will be returning null. If the heap length is 1, we will pop that one, right? We'll be popping that one. Let's see. For that, I'll quickly make use of the if condition. If this dot heap dot length, this is equal to 0, then as I have said, we will return null. So if I like this, yeah. Again, if here heap dot length, this is equal to 1, then we will pop, as I have said, this dot heap dot pop, right? So next what I'll do, let me consider the variable name min, and let's assign this one potentially this one to the first index, nothing but this dot heap of 0, right? So this dot heap of 0, the first index, nothing but the first index here. Let's pop this one by making use of the pop function, right? This dot heap dot pop of pop, that's it. Next, let's make use of sync down this one method here. So we have not written the sync down yet. We will be writing that one next. So quickly let's return the minimum, right? So as I've said, we'll be writing the sync down next. So let's quickly write the sync down. This is the last method, right? So quickly write here sync down. Let me call the sync down over here. So let's initially assign the index to 0, and while of true means it has to be true, boolean value true at any cost, right? To move further. So what I'll do, just give me a second here. Let me set this one, left index, right index, and the smallest. These three let's set. First, let me set the left index to 2 into index plus 1, and let's set the right index now. Right index to 2 into index plus 2. So I hope this is clear. Next, let's give let's assign the smallest to idx or the index. So let's see certain conditions by making use of, I'll just make use of the if condition very quickly. I'll try to explain the same thing. If left index is less than the length of the heap, and I have to make use of this keyword, right? So this dot heap dot, sorry, this has to be length actually, length, and this dot left index we are considering, right? Left index, oh, this left index should be within the array, sorry. And if this is less than the smallest heap, smallest, then we will assign the smallest to left index. So quickly I'll just give smallest equals left index. I hope this is clear. Next, let's do the similar thing to the right index. I'll quickly come here. Right index heap length, this one, this dot heap of, instead of the left index, I'll just consider right index. If it is lesser than this dot heap of, again same thing, smallest, what we will do, we will set the, or we will assign the smallest to right index. So this is quite same, right? So after this, one more condition is, if smallest is equal to index, we have to break out of the loop. So I'll just come here, if smallest equals index or the idx we have considered, we have to break out of the loop. Next, the final one is, we are swapping the index and smallest. So how can I write this one? I can quickly take this one, this dot heap of idx, and this dot heap of smallest. This one has to be this dot heap of smallest. We are swapping this one, right? I should have copied this. This is fine. I'll quickly type instead. Just give here idx, right? And finally, similar to the previous one, we will assign the index or the idx to smallest, right? So I hope this is clear. Next, this is it for the method. Next, what we will do, I'll just come out of this here. So let me quickly give here let heap equals, let's create the new min heap. Nothing but I'll quickly give here min heap. Just give me a second here. And what shall I do? Let's insert 3, 1, 2 by making use of the insert method. We have already written the insert here. I'll just come here quickly, insert here, insert of val, right? So let's make use of the same here. The method insert. I'll quickly give here heap dot insert of any value you can give. In my case, I'll just give 3 here. Let me give same thing here. Insert of any number. I'll consider 1. Let me quickly copy the same thing here. Let me pass some number. I'll just pass 2 over here. So if I try to extract min, if I just give here extract min, what it will do actually, it will extract the lowest number, right? I mean, out of 3, 1, 2, the lowest number is here 1. Next, again, if I try to console log and make use of the extract min and call the extract min with the heap, we have to get the 2. First, we will get the output 1 because 1 is lowest. The second lowest will be 2 and the third lowest will be 3. We are inserting 3, 1, 2 here, right? So I'll just come here. I'll just give heap dot extract min here. Let me give extract min. I'll just copy the same thing. Let me paste it over here. I'm calling this one twice. So the first least element here is 1 that it has to display, and the second least element here is 2. So we have to get the output 1 and 2. Let's try running the code. Let's see what output we get. We have implemented the min heap successfully. Let's see whether this something is wrong or we will get the output. I'll just run the code. So yeah, you can clearly see I am getting 3, 1. This is basically wrong. Somewhere I have done something wrong. I have to get the output 1 and 2 basically. So I am getting the highest this one, right? So basically we are calling the extract min. When I call the extract min, we have to get the lowest number 1, and the second thing we have to get the output 2. So what mistake I have done here is in the bubble up method. So here I am assigning the idx to this.length directly, right? This has to be this.heap.length. So here I have missed the term heap here. So if I try running the code now, so now we are getting the output 1 and 2, right? The correct output. Basically, while I'm calling the extract min method, so we have to get the minimum value. First, we are making use of the insert method. Insert we have already written here. I have explained. So we are just inserting the value, right? We are just inserting the value over here. Bubble up I have explained. Extract min is extracting the minimum. So these two just you have to know properly. So value is inserting the value. What we are doing here, inserting the value and trying to extract the minimum value, right? That's what we are doing here in simple terms. So I have passed, we have inserted the value 3, 1, 2. While I try to extract the minimum, first time when I call the function, I have to get the value 1 because 1 is the least number. Second time if I call the extract min method, I mean I have to get the output 2. So while I try running the code, so yeah, we are getting the output 1 and 2, which is absolutely correct. So we saw how to implement the try as well as how to implement the min heap. And for the other data structures, I have said I have the different playlist for different playlist where I have solved the problems on dynamic programming. This one and other data structures as well, like segment tree, Fenwick tree I have solved, and the other things, arrays and strings, I have solved the LeetCode problems, and these dynamic programming and the Fenwick tree and this thing, I have solved the Codeforces this one problems. I think you can refer that. Please do refer that, and please do try solving on your own. Try to practice the advanced data structures like trie, whether it may be heap, trie, priority queue, whether it may be dynamic programming, graphs, whether it may be Fenwick tree or this one segment tree, these topics. So try to solve some amount of problems. You will get the idea. So this is very easy to understand. So for now, this is it. The next topic that we will be discussing on is binary and the bitwise operations. So for now, this is it. Thanks for watching, guys.